Dear friends, in this video, we will look at one problem that involves the application of t-distribution in a step-by-step manner. As before, I will discuss the problem and the solution with all of you. Let's begin with the problem. An investigator took a random sample of 8 pieces of aluminum die castings and observed the sample mean strength to be 31.5. Before taking the measurement, the investigator knew that the population mean strength for an older type of aluminum die casting was 33. The standard deviation of the sample measurements was 1.3. The investigator would like to know whether the population mean strength of the aluminum die casting is less than 33. Set up the null and the alternative hypothesis, perform the test, and comment on the results. As you can now see, the sample size is 8, small sample size. We have data only on the standard deviation of the sample. Therefore, the population standard deviation is unknown. We will make the crucial assumption that the sample observations are drawn from a normally distributed population, a classic case of application of t-stat. So let us look at the steps now. First step, formulate the null and the alternative hypothesis. H naught mu equal to 33, HA mu less than 33. Because the investigator would like to know whether it is less than 33, this is the alternative hypothesis which you would like to prove if there is evidence. So this is the first step. The second step, select the appropriate test statistic. In this case, it is the t-stat. So t equal to x bar minus mu divided by s by root n. And s is the sample standard deviation. X bar is the sample mean. Mu is the population parameter. And this we will have to select as the appropriate statistic. And we know it follows a t-distribution with n-1 degrees of freedom. Let us now compute the t-stat under the null hypothesis being true. X bar is 31.5. The hypothesized mean is 33, which is mu. 1.3 is the standard deviation. Square root of n is equal to 8 is the sample size. Upon simplification, we have obtained to the 4 decimal places position the value of t to be minus 3.2636. I repeat again, the t computed value is minus 3.2636. Now, what is step 4? Draw the diagram and mark the t-stat value. So t-distribution with 7 degrees of freedom here, n is 8, therefore n-1 is 7. It is plotted for your purpose and understanding. The x-axis represents the ordinate value of t, and the y-axis represents the probability or the p-values for various ordinates, and it is computed here, and the diagram appears in front of you. Now, we have marked the t-stat that is computed in the previous step, minus 3.2636. I just put minus 3.26 for clarity and in the diagram, and therefore I have further simplified to minus 3.26, but I'm keeping minus 3.2636 for computing the probability for better accuracy, but I'm displaying only minus 3.26. in this diagram. So this is marked minus 3.26, which is at the left of the mean, and t distribution is symmetrical as before, like the standard normal distribution. So I have marked it here, the t-stat computed. Step 5, compute the p-value based on the t-stat, and using Excel, I have computed the p-value using the function as before, which is t.dist, which you can do easily in Excel. Substitute the ordinate value minus 3.26, the degrees of freedom, you put 7, and you get the answer here. You will have to also put in the Excel function 1 to represent cumulative graph or cumulative probability. So I have got the value, which is 0.0069, the probability t less than minus 3.26, which is the p-value. Step 6, if the p-value is less than alpha, reject the null hypothesis and accept the alternative. When not specified as before, we take alpha as 5%, and the p-value computed 0.0069 is less than alpha. As you can see, alpha is 0.05. This is 0.0069. Therefore, the null hypothesis is rejected. The alternative HA is accepted. Indeed, it appears mean strength of the aluminum die casting is less than 33 with a level of significance of 5%, and the p-value is very, very small. I am almost 99.31% confident that I'm right, and therefore I conclude, indeed, the mean strength of the aluminum die casting is less than 33. And this is the beauty of the t distribution. I have illustrated with an example, practical example. I hope you have enjoyed the problem. Let us meet very soon with another video. Thank you very much.